the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia. This is part 2 of our podcast series with Professor Michael Regan, chatting about automated and autonomous vehicles. Professor Regan is an emeritus professor with the University of New South Wales Sydney Research Centre for Integrated Transport Innovation, called RCity. Prior to that, he was the Professor of Human Factors with RCity, and before that, he was the Chief Scientist for Human Factors with the Australian Road Research Board. Mike has a Bachelor of Science degree in Psychology and Human Factors and around 25 years' experience in transportation, human factors and road safety research and teaching in Australia, France and the US.
And I've talked about already the systems that are out there. I realised we talked about all of the different levels and the systems that are out there that are level 1 systems and level 2 where you combine adaptive cruise control with lane keeping assist, and level 3 where the vehicle drives itself for most of the time, but it expects you to take back control every now and then. So I suppose what I might talk about briefly now is the future as I see it, based on my understanding of what's going on. The future of autonomous vehicles is really going to be concerned with connectivity. Connectivity is going to be the way of the future, along with the parallel development of full autonomy in vehicles. And the transport system of the near future is going to be one in which autonomous vehicles become connected electronically with the entire road system, and in fact with the rest of the world. And this again makes for a very interesting focus for human factors and ergonomics professionals for reasons I'll talk about in a moment. The thing about connectivity, and I'll explain what I mean by that in a moment, is that it provides additional data that can be provided to autonomous vehicles to improve their performance and safety. And that connectivity can be achieved in different ways. And so, for example, your listeners may start to hear in the very near future about what we call vehicle-to-vehicle connectivity or communication. And this means, for example, you can have 2 cars approaching an intersection. Each of them is operating autonomously. There are passengers sitting in there, no steering wheel. But the vehicles are communicating with each other. And in the future, there won't be any traffic lights, traffic signals at an intersection. The vehicles will just know where they are on the approach to the intersection, and they'll work out a way of bypassing each other in very large numbers through that intersection without you even knowing it. They won't stop. They won't have to stop. They might slow down a bit, but you'll just, if you can imagine it in your head, having all of these vehicles autonomously converging on the intersection, talking to each other electronically, and each vehicle compensating for the movement of the other to get through. And then you can have what we'll have is, we'll also have infrastructure to vehicle communication. We've actually got this at the moment. Infrastructure to vehicle connectivity means, for example, you can have sensors on the road ahead, which are sensing that there's black ice on the road. And that information is sent electronically via a service provider of some sort, just like a mobile phone tower, to the vehicle. And so you get a warning in your car if you're driving a partially automated car, because you can have connectivity between partially automated cars as well, to say there's black ice on the road, slow down or take a different route. But if it's an autonomous vehicle, it will just know what it has to do and avoid the black ice. Then you can have what's called vehicle to infrastructure connectivity. This actually occurs at the moment, where if you've got, for example, fire engines and ambulances, they can actually send a signal electronically to traffic signals to give them priority, so that the lights change from red to green, and they can go through the intersection more quickly because they've got a dangerous activity that they're being posed with, or they're going to a fire, or they're carrying someone who's critically ill. So that's occurring at the moment, but there'll be lots more of that. And then you can have vehicle to pedestrian or V to P connectivity. So a pedestrian might have an iWatch or Apple Watch, and all of a sudden their Apple Watch says car approaching, or car approaching on left, or gives them some indication that they're in danger because of another vehicle or road user. And then you've got what's called vehicle to anything, or V to X, which is really your vehicle connecting to the Internet of Things. So it could be anything. So you come home in your autonomous vehicle, it drives you home, and as you get to the driveway, the autonomous vehicle sends the signal to the garage door to open so that your autonomous vehicle can park. You pre-programmed your car to turn the stove on, so the food starts cooking, all these things. So the car then just becomes connected to anything that it can connect with. So that's the future of transport, basically, connectivity. And there are all sorts of, implications of that we could talk about.
There's so many things that you've talked about, Mike, that I've really not considered. Really, we're driving a computer.
That's right. And what you're alluding to, Sharon, is, the need for the community to develop trust in these systems. And we're going to talk about that in the last part of the podcast, because these vehicles, themselves operating autonomously, and when they're connected to other things out there, they're going to be behaving in ways that we've not experienced before. And so trust is going to be very important. And, there's a lot of work that's being done by people in our profession looking at, how do you increase trust in automated systems? Because if people don't trust them, they won't use them, they might even abuse them. So we'll talk about that.
Yes, Mike, this is great, because this leads really nicely into what the critical human factors and ergonomics issues and challenges are that need to be addressed so that these vehicles can deliver their anticipated benefits to society. That is a neat segue. Thank you, Sharon. Well, look, there are quite a few sort of human factors that are important and have been exposed actually in the journey so far towards full automation. And I'll talk about some of those. And the first one, in fact, is trust. Human trust in automation, we've found, for probably 20 years of research, mainly in aviation, is not entirely calibrated. And what I mean by that is that sometimes our trust in technology is too low, and we call that distrust. And sometimes it's too high, and we call it overtrust. So people could either distrust the autonomy in their vehicles, or they could have too much trust in the vehicle. And I've actually experienced this in my car that's got a couple of these systems. When I bought my car and discovered it had lane keeping assist in the system in the car, which helps to keep you within your lane if you drift out. The vehicle takes control of your steering wheel and makes sure you don't steer off the road. I noticed that there were times when the car was reading the line markings and thought that I was drifting off the road even though I wasn't, and was trying to pull me back onto the road at a time when I wouldn't normally have steered in that way. And at first it scared me, and I could have gone down a particular path which would have been, I think there's something weird about this automation. It doesn't seem to be working properly. It scared me. I'm not going to use it again. So that would be an example of distrust. I don't like the system, so I'm not going to use it again. In my case, what I did was go back to the manual and try to understand and look at YouTube videos to understand, why did it operate this way? And then when I discovered why it operated that way, I could then predict whenever I got into a situation where the line markings were configured in a way that would upset the automation, I knew what was going to happen and I was prepared for them. So even at this sort of level of automation in my car now, issues of trust are an issue.
And so other examples of, say, distrust would be that a driver takes back control of a vehicle unnecessarily in an emergency or doesn't use the automation at all. And I talked about that latter aspect before. So it could be that the autonomous emergency braking activates, it's doing the right job, it's going to save the person's life, but they don't trust it. So they override the automation in that case, and they get killed. And then overtrust could occur if, people in an automated vehicle never encounter a system failure, and so they think that the system's, reliable in all situations and is perfect, but it's not. And so in that one situation that it fails, they're not sort of prepared for it. So trust is a big issue. Another big issue that's been looked at by people in our profession who are doing research is misuse and abuse of automation. And so misuse occurs when there's a lack of understanding of the capabilities and limitations of the automation that can, result in drivers falsely assuming that the vehicle's more capable than it is. And so an example of that of misuse would be a lot of us in maybe slightly older vehicles would have just a simple ultrasonic reverse backing aid or reverse parking aid on their vehicles that, goes beep, 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 beep. And then as you get closer to a brick wall that you're sort of approaching from behind, it goes beep, 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 beep. And then you know that you're, about to back into something. Those early generation systems using ultrasonic sensors weren't actually capable of detecting humans that were walking behind the vehicle, for example. And there have been quite a few crashes into pedestrians that have occurred because people have falsely assumed that these reverse parking aids were actually reverse collision warning systems that could detect, humans and other animals behind them. And so a lack of understanding of the capabilities and limitations of the system can make people misuse them in those sorts of ways. And then, of course, there's abuse. And so if people have, inappropriately high levels of trust in the system, it can encourage them to use the system beyond its what we call operational design domain. So there was a recent Tesla crash, for example, where the person, put the Tesla into, I think, what they call autopilot mode. It was driving itself on a freeway, and it came across. There was an intersection there that the vehicle that came out from the intersection, that the vehicle didn't detect for whatever reason or couldn't, and I think the person was killed. I'm pretty sure in the crash, and it was a case where the person in the vehicle put it into autopilot, assumed it could drive all the way along the highway, but didn't realise that in that particular crash scenario or edge case they call them in the industry, the car couldn't cope. So that's what can happen when you abuse the system, when you try to use the autonomy in situations it's not designed to be used in. One of the big issues that human factors researchers and designers are looking at the moment, because human factors and ergonomics professionals are actively involved in helping engineers and advising engineers in how to design the human machine interface for these vehicles. And in these level 3 vehicles that are partially automated, as I said, they can drive around for most of the time, but when they get into a situation where the vehicle sensors can't operate, or the algorithms that drive them are incapable of continuing to drive the vehicle will tell you to take back control. It'll have a message that says something like, please take back control of the vehicle. And this is a big deal. It's a really hot topic at the moment, because if you've got a driver who's put the level 3 vehicle into automatic mode, if we call it that, and they're sitting there, talking on the phone, or they're sending a text message or reading a book or doing anything. The big challenge is, are they going to be ready to take back control when they need to? And how do you keep the driver sort of in the loop and ready to intervene if necessary? Is the big challenge here. Because if it takes them too long to take back control, or if they take back control in a way that's not optimal, the car will crash. And so here the human factors engineers, need to provide advice on, how much time should you give them? How should you design the interface to reorient their attention to the area of the forward road scene that's most critical for them to focus on when they put their eyes back on the road? How do you sort of keep them, alert while they're driving in automated mode, so that they don't, so that they have the capacity to take back control? So this, what we call transition of control issues, a really big one in the human factors area. It's a real challenge at the moment to try and get right. Another issue is skill loss, because we know from research and all of the things I'm talking about are things that have been exposed through research. Human factors researchers in particular have exposed all of these things as issues that need to be dealt with. And we're providing guidance, as I'll say later, on how to deal with them. But skill loss is a big issue. Gradual loss of skill is going to happen if drivers haven't been in control of the car for a long period of time, if it's a level 3 car and they've been relying very heavily on the automation. So I'm talking here about partial automation now, not fully autonomous vehicles. And research has shown that, by, being out of the control loop for prolonged periods of time when the vehicle's driving itself, it can make, human drivers less confident in their own performance, and hence less likely to continue to want to use the automation. More critically, it degrades their ability to intervene if they're required to take back control. And that's a big issue in aviation. And we know that there are many people in our profession who've worked with pilots, developed training programs for pilots over many years, in which pilots have had to keep going back into simulators because they fly so much on autopilot in large commercial aircraft, to prevent this loss of skill. What they're doing when they're hopping into the simulators is practicing the skills they need to operate that plane if they have to take back control in certain situations. And there are some situations, for example, in which it can be very difficult or impossible for a large commercial aircraft to land in bad weather conditions or other conditions, and the pilot has to take back control manually. And so they spent a lot of time practicing, landings. So that's an issue. And then education and training is another, big issue. And I've alluded to this before, that when I'm driving my car, for example, and I've got the level 2 automation on, the role that even though I'm in control, what I'm doing is slightly different from what I'm normally doing. What I'm normally doing is putting my foot on the accelerator, keeping a safe distance from the car in front, and steering the steering wheel, maintaining my lane position. Now what I'm doing is slightly different. What I'm doing is I'm looking at the road ahead to see, and what I do with level 2 automation is I keep my hands lightly on the steering wheel and let the car drive itself. And so, the skills required now are not to drive the vehicle, but just to let the vehicle drive, but to be constantly checking to see whether the vehicle is performing as it drives itself in the way that I would be driving and I would expect the car to drive when I'm driving. So I suppose what I'm saying is that it's a different skill now. It's a skill of being able to compare what the car's doing with what you would do, And if you think the car's not doing what you would do and you feel uncomfortable about that, taking back control. So it's a different set of skills. It's sort of more monitoring what the automation is doing. And so from an education and training point of view, there are quite a few sort of critical things that we need to convey to people. We need to give them, knowledge of the conditions that are unsuitable for use of the system. We've got to give them skills in recognising conditions that cause system performance to be ineffective or degraded. And we need to train in them the behaviours that make them willing to use the system when it's appropriate to do so that it has the effect of that we want it to have, which is to make them safer.
Coming up in part 3, Professor Regan will chat about the challenges that the human factors and ergonomics community has in addressing the design of these vehicles. Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.